Thank you. I'm really happy to be here. And yes, indeed, I didn't even actually assemble the pieces of my talk until last night because I wanted to wait and see what happened yesterday and have that inform what I might be able to share with you all this morning. And I'd actually like to start by reading you something. If you bear with me, it's just a short paragraph here, but it's an important context to set for the stage today. This is from Henry Beston, who wrote it in 1928 in one of his books. We need another and a wiser and perhaps a more mystical concept of animals. Remote from universal nature and living by complicated artifice, man, in civilization, surveys the creature through the glass of his knowledge and sees thereby a feather magnified and the whole image in distortion. We patronize them for their incompleteness, for their tragic fate of having taken form so far below ourselves. And therein we err, and greatly err. For the animal shall not be measured by man. In a world older and more complete than ours, they move finished and complete, gifted with extensions of the senses we have lost or never even attained, living by voices we shall never hear. They are not brethren. They are not underlings. They are other nations, caught with ourselves in the net of life and time, fellow prisoners of the splendor and travail of the earth. I wrote that in my diary when I was 14 years old. And I realized that the other day, like, oh my God, I've been doing this a long time. And this was a time in my life when in the United States they were asking us to check off what our ethnicity was in boxes. And I would either check Native American or other because I wanted to completely ignore and avoid my suburban white roots. I hated that part about me. And when I was asked, what historical figure would you like to go back in time and spend a day with? I always wanted something like Sacagawea or, something a Native American, yet unknown and named, and to live in that time. And thankfully, to the anthropologist yesterday, I learned that I'm an animist. And I never knew that's what I am. But I am an animist, and I'd like to share with you a little bit why I've come to that realization. It's an important part of who I am. But I'm a biologist by training, but nevertheless, I hold every single species on this planet, which is at least 30 million. We've only given names to 1.8 million of them. But there's at least 30 million. But yet, these 30 million species represent less than 1% of all the species that have ever lived on the planet. So there was a lot of bad ideas that went extinct or had bad luck or, some combination of the above. But they're fascinating. And I just want to share a few of them with you today. So I hold these other organisms on a pedestal probably even higher than us, my fellow species, for a few of the following reasons. Maybe it's the lotus and the fact that it can stay completely clean without the use of detergents. Or the Namib beetle, which can harvest its own drinking water from the fog. Or the desert mullock, which can actually wick enough water to sustain itself out of damp sand alone. Or maybe barnacles that spend half of every day completely pounded by the waves and the other half of the day basking in the sun and live to tell about it. Or being able to make color without the use of pigments, amazing structural color like we might find in this chameleon. Or to be able to grow this amazing reproductive body, massive amounts, like within hours, you can witness it growing before you. Or to be able to sense a tsunami 10 to 15 minutes before it hits the shore through the bottoms of your feet. Or to come together when you need to solve an important challenge and to come across and overcome barriers, or to create entire ecosystems building on a grain of sand. To have a proboscis that unrolls, and then you roll it up when you don't need it. I mean, who wouldn't want something like that? Or to be able to take chalk, soft, soft chalk, and assemble it in incredibly intricate crystalline structures that are far stronger than any ceramic we make today.
And who does that?
That's a sea urchin. Or to be able to hear a mouse this big scurrying under 3 feet of snow and design your dive so that you hit that mouse once you get through the snow of the trajectory. Or wouldn't you love to walk this way? Or capturing just as much water from the sky and storing it as your roots can grab out of the ground. I mean, leveraging both directions, tapping into both worlds. And who needs Dr. Seuss when you look like this? I mean, like, there are so many fantastical creatures already out there. We don't even have to make them up in our own imagination. Or the waggle dance. I mean, who invented dancing? It wasn't us. Far longer than we've been around. To create your own home and carry it around with you at all the time. All the shelter you need. Pull back in, come back out, pull back in. Or as we learned yesterday, to eat sunlight, right? The most readily available resource on the planet, and that's your food source. Pretty smart. Or to create entire ecosystems just by your very presence alone. And without you as a species, nobody else can live there. Imagine if we could claim that. To cooperate, to create cleaning stations. This is this mound that this shrimp owns, and all the fish in the reef know, and they come. Say, hey, my turn, car wash. And to be so incredibly, I think this is about the sexiest, sensual picture from the natural world that I can imagine. Imagine being able to do that kind of backbend. And to leverage and get into niches that you could never even imagine could be accessible to us. And to design your adaptations to truly fit in. Or a butterfly that spends half of its life as an eating machine, wraps itself up in a cloak, and then digests its own cells to feed its next generation, its next version of itself as it metamorphizes and then just lives for sex alone. I mean, what an awesome life, right? Right? Or think about a cooling strategy that the zebra uses, black and white. It creates its own convection currents to keep cool. Or to spin a fiber that is ounce for ounce stronger than steel from chopped up fly parts, right? Or to have eyes that can see and to grow so large that you could engulf a human being, but yet to have no brain, no central collection of neuronal axes. This is a giant clam. They can grow to be 1.5 meters. To exude your own lubricant and slide around and have everything. I mean, this is far more effective than my roller bag. I'm telling you, it can go across anything. To create your own defenses only in the amounts that you need, only when needed, on demand, and not be on this constant sense of alert. To have each other's back at all times. Right? And to be just funny, really, really funny. You know? And to create places of quiet and solitude, and as we learned yesterday, to have these massive stories of connections between you and your fellow giants, wherever you are. And most importantly, to withstand the test of time. Because as a species, and I look at ourselves right now and I go, yeah, there's 7 billion of us. And yeah, we've colonized every single continent and just about every square inch of this planet. But will we actually stand the test of time? That's where our ultimate challenge as a species is today. And that's all here. Every one of those species is here, right? Where we live, our home. But the key is that it's not ours alone. We act as if it's ours alone, but it is not ours alone. And I want to put something in context, because yesterday we talked a lot about, our role as humans, and even in our language, we had a very human-centric view of this place where we are. And I just want to put a little bit of a twist on that perspective. So we know that 4.567 billion years ago, our sun was formed. Okay? And I want to take that time, actually 4.5 billion, because 67 million years after the sun was formed, Earth was formed. And I want to take that 4.5 billion years and compress it into 1 year. Because honestly, 4.5 billion doesn't sound like that much. I mean, we live in a country, most of us, where we have trillion-dollar deficits. So, like 4.5 billion, that's, it's like a day on the stock exchange of Apple or who knows what. But it's a huge number. So let's take that year and compress it into 1 year. So January 1st, right past midnight, is when the Earth is born. And we're standing on December 31st, just a breath before midnight, here in 2014. So January 1, this lovely rock appears in the middle of the cosmos. And it takes about 6 to 7 weeks of that primordial soup and volcanoes and lightning and all sorts of chemistry and crazy things happening before life shows up. So we consider February 25th life's birthday, okay, in that year. And these are stromatolites. They're the earliest life form, and they're still here today. Okay? They're still here on this planet 3.8 billion years later, off the coast of Australia, and even in some of the volcanic craters in Mexico. I've seen them. And then it takes about another month for life to figure out, I should capitalize on that sun and photosynthesize. So now you've got all of these organisms, single-celled organisms, floating in the sea that are leveraging that sunlight and photosynthesizing, and therefore changing the atmosphere towards a more oxygen-rich one. But April, May, June, July, and half of August, it is single-celled organisms dominating the oceans and flourishing and mixing and doing all sorts of adaptations to living on this planet. And it's not until August 16th that we see any record of multicellular organisms show up in the fossils. Right? So it takes a long time before cells start coming together and figuring out, what happens if two of these things connect, and what kind of interactions might happen. And then it's a full month later before sex. That's a long time to wait, but there you go. And then you've got the mixing of genes. And when you get to mix genes, you mix ideas, and you create entire new possibilities. And when that happens, over the next 2 months, life begins to figure out there's other places than the ocean to spend time on. And it begins to colonize the land. And the fungi, which we heard so much about yesterday, are the first there. They figured out, they're the early ones to figure out how to make use of this soil. What nutrients can I pull out? How can I leverage the minerals, the phosphorus, and whatnot? In the soil, they set the ground. But meanwhile, in the sea, we have vertebrates eventually developing. You actually start seeing fish show up in the sea. But mind this date, right? We're near the end of November since the beginning of the birth of the Earth. And then about 6 days after the fungi appear, then the land plants. Now they've got partners. Now they can also colonize terra firma. And then very soon after the land plants, we have insects, because there's very, very close relationships between the insects and the land plants, which we know. Amphibians crawl out of the sea, and we see them on December 2nd. All right? And they're more closely tied to the sea with their skin that has to can maintain its moisture. It takes about 4 more days before the reptiles show up. We're in December now. Okay? reptiles just show up on December 6th. Mammals, the ones when we usually refer to when we think of animals, the default assumption for most people, December 13th, right? So we're running out of time in our year, if you've noticed, for a lot more things still to happen which describe life as we know it. Birds are still 5 more years later, or 5 more days later, thank you. And then, believe it or not, flowers have only been here 11 days. Only 11 days. And then the dinosaurs, right? We learned they went extinct a really, really long time ago, right? 65 million years ago is when the asteroid hit the planet and took them out. They dominated for 300 million years. And then they had some really bad luck on Christmas Day, about 6:30 in the afternoon. Right? And the asteroid that hit blanketed the planet with dust. The mammals survived because they ate the rotting carcasses of the dinosaurs until those clouds lifted and plants could grow again. And our ancestors, the first 2-legged hominids to crawl out of the trees and begin walking across the savanna prairies, still just our ancestors, not even our species, showed up today, 11 or 12 and a half hours ago. And our species, no, we've gone 365 days. Our species showed up 24 minutes ago. We've been here as a species just 24 minutes. And the vast majority of that time, in fact, 95% of that time, was what we can consider the Pleistocene, what we consider the hunter-gatherer part of our history. Agriculture, when we finally started settling down, all right, after 365 days of life on this planet, was just 1 minute ago. So the last 10,000 years is 1 minute of our entire existence as of the planet. Right? We've been here just 1 minute. And even more important, for all of us that are trying to solve challenges today, especially in our industrial world, the entire Industrial Revolution, which is the vast majority of places where, we look for ideas and try to figure out how to make things work. 2 seconds. 2 seconds of the whole year. But yet somehow we have some notion that we're like life's evolutionary pinnacle. Like this is what the trajectory was all about. But the reality is we still have about another 5.5 billion years of the sun's life left, which means that we have another 13.5 months of evolution ahead of us. Whether we're part of that gene pool still is an open question. But life will continue on for the next 13.5 months. Can you imagine what's happened just in the last 10 months? What could happen in the next 13.5? So then we have to ask ourselves, is human intelligence the key to our survival? And that's ultimately where my passions lie, is I don't actually think so. I think that yes, we can definitely rely on our ability to communicate and to observe and to mimic and to emulate some of these other practices. But really what we need is we need to find life's operating manual. We need to find the directions for how did life figure it out for the last 10 months? How did it create this amazing wonder that I presented to you in the beginning? And couldn't we learn from that if we could find it? We know that sea turtles, for example, have been following those instructions for 215 million years, right? Which is a really long time. We're like 200,000 as a species. Insects, pollinators, that relationship, they've been practicing together for about 100 million years. They've had a little bit of time to figure it out. Elephants have been fine-tuning their techniques for about 60 million years. Us, not so long. Right? So should we only ask each other how to do this? Maybe. we could try, and certainly the extension to the indigenous cultures, which have been asking their other relatives and the other natives far longer than most of us have. But maybe we can actually do that asking of ourselves and recognize that there's some really important things. We know that life honors the interconnected and interdependent web. That's sort of an emergent default property that is part of their success. And we know that life optimizes in all aspects, all its strategies, and maximizes in none. And we know that all of this has happened on Earth, Earth's operating conditions. The same conditions that have been true for the last 4.5 billion years are still true today. And if we can understand how life has learned to adapt and live in those operating conditions, so might we also. We know that the Earth is unique when it comes to gravity and sunlight and water, right? Those are things that define our rock in the sky. We also know that there are real limits and boundaries out there. You know, and the American model especially is if you're told there's a limit and boundaries, how do I get beyond it? Whereas life has said, well, yeah, okay, how do I tap the power of those limits and boundaries? We know that there's cyclic processes. Those are true of the planet. And therefore, you can either learn to work with them or you can pretend like they don't exist. And most importantly, we know that change happens. We know that the planet is in a state of what we call dynamic non-equilibrium. And the best way I can describe it is imagine that there's a bowl. And that bowl is always moving. And life is sitting in that bowl. So the planet is the bowl is always moving, life is sitting there. And you have two options when you're going to live in that bowl. You can either design yourself to be square and then do everything you possibly can to try to hold that bowl still, which seems to be humans' modus operandi. You know, we add heat, we add temperature, we add dikes, we add dams. We try to hold that bowl still. Or what we have learned from life is that life chooses the round option and goes with the flow, because that is an operating condition of the planet. So if life has learned to flourish under these operating conditions, couldn't we? I mean, shouldn't these brains do us some good and help us figure out what that means? So we've been asking ourselves that question, and as biologists, we've said, well, what are the deep patterns? What do we know that all of the species who are here today share in common? And we call these life's principles, and I'm going to share them with you just very briefly because I spend like a full semester on these next 6 slides, and so I obviously can't go into any detail, but I want to share them with you as a sampling. And imagine if these became your instructions. If these became your instructions, our instructions as a species for how we run our lives, how we run our businesses, how we create things, how we design. Because this is what all of other life has done, and if they've done it and survived, then maybe if we do it, we could survive. So we know that life is locally attuned and responsive. It fits in place. The indigenous cultures fit in place. Those trees fit in place. That is that feedback, that intelligence, that information flow, that's fitting there, fitting in, and being locally attuned. Critically, critically important. But at the same time, you're in that shifting bowl. So you have to adapt to the changing conditions. You have to be attuned, and then you have to keep attuning because life is constantly changing. And you have to build in resilience, a very important thing for ourselves as a species and everyone else as the planet begins to warm and change and go through the dynamics that are still before us. And then, of course, you have to evolve to survive. With some random exceptions, like horseshoe crabs really haven't changed very much in the 150 million years they've been around. Just about everybody else is constantly evolving to survive because the planet is shifting, the planet is changing. Your compatriots on this ship in the sea are changing, and therefore you've got to learn to adapt and evolve and change with them. But at the same time, you have to use life-friendly chemistry. You cannot pollute your own nest. It's not a good idea, as we're all learning more and more and more. Life is also incredibly resource efficient, not just with materials, but also with energy. It needs to make sure that it optimizes the flows and the inputs and the outputs. And we also know that life integrates development with growth. It's not growth at all costs. I mean, do we really expect that we could grow an economy endlessly? Do we really think that we could just extract resources forever? That there needs to be that integration of both development, the infrastructure, and the growth. So these are a very quick view of some of the principles that one should be thinking about following, but in order to do so, we have to be able to quiet our cleverness. We actually have to remind ourselves that we are infants on this planet. We have to put ourselves back in the mind of a child who knows they don't know how to live here, and they ask us, wise experts, the adults, how to live on this planet. But maybe we're the kids, and we should be asking the wise experts of the planet, how do we live here? How do I figure that out? We're not rewarded anymore for what we ask. We're rewarded for what we know, which is really convoluted. That doesn't create any opportunity for learning. And in doing so, and in quieting our cleverness and reaching out and asking nature for help, saying, can we borrow your recipe? That is what biomimicry is. That's what I'm doing. That's why I'm here and what I'm talking about, is the conscious emulation of life's genius, making the choice to intentionally go out and identify those lessons that one can apply. And we've actually chosen these 4 words pretty carefully. Conscious does imply there's an intent. There's a recognition that there's value in doing so. And emulation is also really important. We're not photocopying nature. We're drawing and pulling on those design principles. We're finding the context in which they apply and trying to understand how those contexts fit in which we need those strategies and those solutions and where we can use that recipe. And nature's genius, well, as we've been talking a lot here yesterday and we'll talk more today, inherently I think everybody in this room accepts and understands that there's quite a bit of genius in there. And hopefully, as you've seen, 10 months of surviving on the planet for 3.8 billion years, it's got to count for something. So we like to think of it as bringing together biology, our understanding of all the other organisms, nature, life, however you want to define that realm, and our need for design and innovation and technology. And I use those terms rather loosely. We're all designers in this room, even if it's not in your job title on your business card. You create things. You create systems. You create communication patterns. You create conferences. You create relationships. And those are by design. And couldn't we ask at all times, how would nature solve this? And you won't be surprised to know that while it is an emerging discipline, it has an ancient practice. We've just forgotten. A huge piece of this is remembering. Not just remembering here, but remembering. Becoming members once again on this planet. But when we surround ourselves with these walls and these curtains, and we don't even know if it's sunny outside or not, we forget to ask those questions of everybody else who's kind of figured it already out. So we look to nature as model, measure, and mentor, and it's a very different way than the last 250 years have been. The industrial age was about what we can take. We took soil, we took wood, we took minerals, we took oil, we took plants. And that's all an extractive, one-directional relationship. This is about what we might learn, which sets up an entirely different dynamic. It changes the language that we use when we talk about the natural world. And when we talk about biomimicry, we have 3 critically important elements. We have what we call the ethos. Yeah, it's one thing to learn from nature about, say, learn from a tuna fish on how to design a better nuclear warhead, that torpedo that swims like a tuna fish so it doesn't detect by sonar. That doesn't fit in my book as learning from nature. Yeah, you learn from nature, and the engineer probably has a whole new respect for tuna, which is great, but it kind of defeats the purpose. And so we believe that if you're going to ask, you need to be asking the questions that are not just conducive for our lives, but are conducive for all of life on this planet. And another big important piece of biomimicry is that reconnect. To no longer have this divide in our language, in our perception, in the actual tangible notion of our connection to nature. We are nature, and thankfully Jeremy spent some time with us yesterday on that very topic. But we have to reconnect, and in some places we have to connect with nature. I meet far too many people who can't remember the last time their feet touched a non-man-made surface. We can't live that way, or we won't be here long. And then the third piece is to emulate. All right, this is the part which you might see in the media. These are the case studies. These are the cool relationships. And, oh, look, we learned from this, and we created this. And I'll share some with you because they're really cool stories. And what I love about biomimicry, and it occurred to me yesterday as being really, really important, is a lot of the people that I interact with would have a tough time sitting in this audience yesterday. They would be like, "Woo, I'm out of here. This is not working for me." But biomimicry creates a door in because they can discover new innovations, new technologies that they might perceive as being, I would perceive as self-serving, but that's okay because I have them in the door. And now I've got them convinced to go for a walk with me in the woods. And when we start doing that, suddenly the other facets of biomimicry become accessible. Suddenly that ethos and that reconnect and that engineer, yes, really is fascinated by tuna and is suddenly studying that much more in the ocean and going, you know what, maybe we aren't really doing things the right way. So it becomes a really critical entry point into these other facets which are just as valuable and makes them that much more accessible. So when we look to biomimicry and we look to nature for advice, we can emulate at many, many different levels and scales. We like to categorize it as mimicking form, which is the shape, the structures, the patterns that we can physically see. And those are rather relatively easy to do because you measure the pattern and you recreate the pattern. And it's our limitation if we're unable to, our lack of creativity, but you can measure and you can see it. And we can kind of understand what that's about. But you could also emulate not just what nature is made, but how she's gone about making it. What are the processes? Imagine if we could figure out how to eat sunlight. Right? If we could actually figure out how to recreate photosynthesis. Solar cells are not photosynthesis. This is totally different processes altogether. But if we could figure out how to do that, and there's some great work happening at artificial photosynthesis labs around the world, including some great work at Arizona State University that has a lab called Artificial Photosynthesis Lab. And then there's the ecosystem level. So not just what we make, how we make it, but how does it fit in the larger ecosystem? How does life do that? It's not all these random organisms operating in a vacuum. As Suzanne shared with us yesterday, you can't exist without your coexisting partners. You are deeply embedded and connected. Where you get your raw materials, where they go at the end of your life, that's all part of the larger system. It's a little harder to emulate that. We're tied in a pretty complex system as it is. But that's where the ultimate goal might be. So let me share with you a few examples to give you some real tangible things. And this is really just a very small subset, but I wanted to give you something to orient around. I was in Hamburg last week at a charrette to help design the world's first sustainable cruise ship for a company that does peace cruises. They're all about building ambassadors between communities, and rather than landing on shore and going to the jewelry and the the liquor shops, they go up to the orphanage and volunteer at the orphanage. It's a really impressive organization out of Japan called Peace Boat, and they want their ship to also be an ambassador as it travels around the world. And I'm sharing this with you because I had to give a presentation there, and I found 50 existing products, case studies on the market that had direct application to the ship. And so it's just, there's so much happening, and I can't even keep track of it anymore, which is really cool. I mean, sometimes it's intimidating because that's kind of my job. I'm supposed to keep track of it, but there's too many, which is the really good news. So this is a project that came out of MIT. This is solar thermal. So it's reflecting the sun onto a central pier, that white light in the middle, that boils and creates steam, and the steam runs steam generators in order to create electricity. And of course, in our classic linear box mindset, we set all these things up in exact, almost a grid, even though it was round around the center. And then someone said, well, what if we try to optimally pack these solar panels into one spot? And they looked at sunflower heads, which of course are all about how do you get as most seeds as possible into one head. And that optimal packaging arrangement turned out to be the most optimal array, so you could get that many more solar panels and a much smaller footprint for the amount of energy you were trying to generate. Not that complicated, right? You just ask. This was a designer in Portugal who was tasked with lightweighting plastic bottles and trying to make his bottle as thin as possible. And so he went to our website called asknature.org, where you can type in, how would nature solve X? And we have a few thousand strategies, which is barely scratching the surface of the 1.7 million species, and many species have many strategies to offer. But it's still pretty cool. And he went in there and said, how does nature create strength? Because that's what the weakness in the bottles are. And he came across these white bark pine as a strategy. And the white bark pine, which lives up in really windy environments, twists. And it grows with a twist. And that twist creates that tensile strength that it needs. And he said, that's a deep pattern. That twisting can create strength. And so but it's not a perfect twist, right? It's not an exactly parallel twist. It's a bit of a random twist. And he found that if he built in these random twists, not only was it a really beautiful, as if you could think of a plastic water bottle as being beautiful, more aesthetically pleasing than the standard bottle, but he was able to eliminate 18% of the weight of the plastic. And when you're talking about a massive amount of water bottle production, that's a huge significant savings, both in weight and raw materials and ease of recyclability and so on and so on. Simply by asking, how does nature stay strong? This company comes out of Germany, and they were addressing the problem of the 350 million birds that die in Europe alone every year from crashing into window glass. There are people whose job is to get up at 4 a.m. and sweep the sidewalks so that we don't have to witness the carnage of what happened every night. That's a lot of birds. And they said, well, why is it that a bird can fly through the forest and it doesn't crash into spider webs? I mean, it sees those. What's going on? And so they asked, what is going on? And it turns out that spiders, when they spin their webs, they don't really want the birds to crash in their net webs either. Right? Bad combination. And so they spin into their webs small fibers that reflect ultraviolet light. And birds see ultraviolet light, but we do not. Perfect. So this is kind of a super close-up of the glass that they created, and when they create the glass, they put in fibers that reflect ultraviolet light. And we don't see them, but the birds do. It reduced crashes by 99%. Right? Beautiful, beautiful. Fireflies, right? Their life depends on their ability to find a mate. right? And they've got to flash as bright as they possibly can. So they might be a good strategy, some organism to look at to help us understand how to create bright light. And so that's exactly what LED manufacturers are doing. How can we get the most light out of the light that we're creating? And it turns out, this is a great form question, they looked at the abdomen where the light is emitting under a scanning electron microscope and found out that it actually was the shape of the scales that allowed that light to reflect at up to 15% more brilliance than without that kind of structure alone. And not all that complicated of structure to recreate in the lab. There's a scaling piece that they're working on now, but they can enhance the light. And therefore, you're talking about energy reductions, enhanced functionality, and so on. A big problem in our shipping industry is that you have barnacles and you have a whole biofilm, a whole bio-community that naturally finds these surfaces pretty attractive. And that creates drag on ships, which uses up a whole bunch more fuel. And so these researchers asked the question of, well, you know, why aren't fish swimming around with a bunch of barnacles and drag? I mean, there's got to be some lesson there. And if you've ever fished or you've touched a fish and you pick it up and there's slime on it, well, that slime is a biofilm. It's actually the symbiotic bacteria that have formed a community on the surface of the fish. And basically, they sort of snub their nose at all the rest of the bacteria and go, we got here first. And they maintain that surface in a symbiotic relationship with the fish. And so this company, Luritech, developed a coating that doesn't have copper in it, doesn't have arsenic in it, but invites the bacteria in the sea, please come land on my ship. And you become our biofilm and keep all of the rest of the encrusting organisms at bay. Right? Completely different way of thinking about solving our challenges. Ants and many other organisms like fish and birds that swarm or flock must have some pretty darn amazing communication systems, right? And we might like to think that there's this fancy, complex way, but actually there's just some pretty simple rules. When birds fly, it's basically, okay, maintain 2 inches between you and the wing of your neighbor, you know, at all times. And that's it, you know. And when they're all following the same simple rules, you have this emergent pattern of self-organization. Well, those deep design principles can be mathematically modeled, and they're being used in lots of different applications. This is one of the more recent ones, learning from ants and changing those simple rules around the timing of traffic lights. And by changing the timing of traffic lights, of course, as you might imagine, it reduces stress, which is very good, because people are sitting at stoplights far, far shorter. It reduces time anywhere from 20 to 30 minutes in this particular city from transport across the city by timing the lights more effectively. And, of course, that reduces emissions and fuel consumption and all of the other benefits from that. Lots of applications of it's called swarm theory that looks into how information flows. Again, another rather simple one. When fish school together, they're not individual fish just trying to maintain a certain distance so they don't crash. They're trying to maintain a certain distance and an orientation so they can leverage the vortex that's coming off of the fish next to them and save their own energy. They actually use vortices behind rocks. When they propel themselves upstream, they're using that to their advantage. And so when they school, they're also using less energy because the fish next to them is creating a frictional byproduct of a vortex, and they're doing that. So these folks at Caltech have used that same idea to better orient wind turbines so that the next wind turbine can borrow the vortice from the first wind turbine. This last example is a little bit of a personal one. We seem to have a theme happening here. I, too, was diagnosed with breast cancer last year. And, but I chose a biological approach. I chose a biomimetic approach to dealing with mine. I had stage 3 breast cancer, and I decided that I wasn't going to choose the industrial model for myself. And I asked the question of what would nature do, and how would nature solve this? And came upon biological medicine in a clinic in Switzerland that practices this. And in essence, it asks the question of, if you have a weed growing in a field, how do we address that weed? The industrial model is to go in with a backhoe, a blowtorch, and a big, huge mass amounts of Roundup to address the weed. But nature says, well, I wonder why that seed got established here in the first place. What's going on with the soil? What's going on with the other plants? How can we intentionally create something that inhibits just that weed that doesn't belong in this ecosystem in the first place? And that's the approach that I took, and I'm healthier today than I've ever been in my life because of that, and thankfully was able to avoid that other approach. And so there's applications in places where you least expect them. And I wanted to share that with you with our arm cutting off shaman story from yesterday, that there are opportunities to tap into something that's even incredibly scary and life-threatening, to ask the nature of wisdom, or the wisdom of nature of wisdom, maybe the combination of the two, to help us through these times. But what I do know from all of this, whether it's the examples that are personal or the examples that are out there, is that life creates conditions conducive to life. And if I ever want to be proud to be a human, I'm not there yet, honestly, so I'm not sure if animism is even quite the right term, because I put other organisms above being humans. I want to be able to replace that first word, life, with us. That we as a species also create conditions conducive to life, and that we're not going to be added to the 99.9% of the species that went extinct. Because the reality is, if we all disappear tomorrow, we get sent to a penal colony on the moon, some aliens come and abduct us, whatever it might be, all traces of us on this planet, with the exception of a few radioactive pools here and there, will disappear in 170,000 years. That's like another 20 minutes on the age of the planet. So we're just here for a brief moment, quite potentially. I actually find that very comforting, that it's only going to take 170,000 years to fix this problem. But maybe we can be around a little bit longer. So where do we begin? Where do we go? How do we start? Well, here, right? Outside, your backyard, your neighborhood park, where we still have nature around us, thankfully. And we can tap into that, and it's accessible to all of us. You don't have to have gone to school to be a biologist, to go out and ask, how is nature doing that? To have that curiosity, because we have to get back in this position. When was the last time any of you in this room were in that position? Right? The position of curiosity, awe, and wonder. It's my children many years ago, and that's the position I see them in quite a bit. And that's what we need to rediscover for ourselves, because, again, we are just infants on this planet, and we've got to get back in that sort of mentality so that we can collectively say we create conditions conducive to life. But that will only happen if we can embrace the wisdom that's out there. We have to be willing to say we can't do it alone, and therefore we have to ask. And then, when we do that, we begin reconnecting with our own humanity, what it means to be a human, right? Maybe that's what it's all about. We ask ourselves, why are we here? Maybe that's what it really ultimately means. Because we are nature, right? We learned that yesterday. We have to constantly remind ourselves, and we have to check our own use of language, because that language that we referenced yesterday does dictate how we see the world. As scientists, how we do our research, we like to believe that we're objective, unbiased, researchers that have nothing to do with the way society sees things, which is a farce, But how we reference our connection determines how we live our lives, how we go about every aspect of our day. And I put these eyes up for Jeremy. This is a stone plant that conveniently is growing in an eye-like pattern. Actually, what is really cool about them, this looks like it has color, but it's actually transparent. So the photosynthetic material is underground, and it's like a window pane. So it very much is like eyes bringing that light in. The next generation is asking us, right? Begging us, screaming at us. And if any of you have any children in your lives, which all of us do, whether they're your own or your friends or your family or your neighbors, it behooves us to be able to answer the question, what the fuck were you doing? Right? I'm sorry, But fortunately, right, we are surrounded by genius. And that is where all of our hope should lie. So, thank you for your time. I got a couple. There's one up there and maybe here. You were super fast with your hand, so go.
Where did you get those incredible photographs? And who put that together? That was beautiful.
Outside.
Okay. But serious, well, no, I guess that's serious, but
that's
that is
totally
an incredible group
answer.
of photographs. Did you take them all?
No.
Okay.
No. I am grateful for the numerous people in the world who view nature in a different way. And it is a lens that we use when we select our photos, is I want to show you nature in a way that you've not looked at it before, right? We all see the elephant but how many of us really took time to look at its feet? So we choose those intentionally.
It's the brilliance of choosing that you did. Thank you so much. It was incredible.
Thank you.
I think when I first got the whole Earth catalog, I saw Ian McCart's Design in Nature, but I read it and can't remember. Do you remember his impact on this whole field?
The field of biomimicry has... it's come and gone and come and gone and come and gone. Of course, we have the first 190,000 years when we did it, and then we stopped for a little while. We see surges like Da Vinci was a biomimic, and Gaudi was a biomimic, and then the Russians actually had a whole field of bionics in the 60s. More oriented towards human performance, but they looked. And then there was another sort of, Bucky Fuller, Ian McCarg. Some of in the energy crisis in the 70s, we began to start asking some of those questions. What I've seen now, I've been working in this field now for 16 years, is it feels like it's more here to stay. We're trying to find methods and mechanisms and embedding it in practice, in academia, in our culture. And it feels like it's got some roots. So I'm hopeful that it'll stay.
One comment too, on Southwest Wisconsin, which is the Driftwood Zone, there's just a year ago they put out a film called Mysteries of the Driftwood Zone. It's just amazing. You can Google it and the trailer will come.
Great, thank you. Yeah, our own backyards still have so much to discover. Exactly. You don't have to travel too far. One more. Okay, right here.
You're speaking to the choir. Do you ever talk to religious leaders, for instance, people who
who want to keep their culture exactly the way they think it should be and are not perhaps knowledgeable about biology. You know, a crash course in biology is something, well, everybody needs that.
I think, yeah. I mean, one of the things we're trying to do is to get biomimicry, biology taught functionally as the biology for non-majors class, right? Because then it's suddenly relevant, rather than being about human biology, which of course is very relevant, but no matter what discipline you go into. So you said, speaking to religious leaders who don't want to change their ways. Well, I talk to business leaders all the time, right? who are like, this is kind of the status quo. Yes, and actually, there's always the question of what role does religion play in this, and as far as I'm concerned, I mean, yes, I am a card-carrying Darwinist, and he didn't get everything right, but he got a lot right in my book. So even if you believe that God created all this and we're supposed to take care of it, then maybe he created it for us to learn from. And, so there's still the opportunity to build those connections. And so you might not mimic genetic algorithms, which mimic evolution and natural selection. There's a lot of other things and opportunities to tap into. So the beauty of biomimicry is it can almost fit everywhere. You're right. I'm talking to an audience here that I love. It was great to play at the facets, because most of my talks spend far more time on the case studies, and I got to spend more time on the other deeper meanings behind this. But yeah, I haven't yet, with the exception, and this is important because we talked about it yesterday, come across anybody who doesn't go, oh yeah, that makes sense, except for people who have put humans on a pedestal, who believe that humans are the superior species and we're far better than anything out there. If at least you're on a parallel, or you're open to the possibility, then it makes sense. But it's that pedestal that becomes an impediment.
You could argue that's perhaps our biggest problem.
It's definitely a hindrance. It's definitely a roadblock, for sure. So, thank you. Sorry I didn't have more time.